Welcome back, students. Today we are going to introduce the simplest deterministic theoretical machines, which are called finite automata. So finite automata is actually equivalent to regular expression. It is just another way to define the same thing. Whatever language you can define using regular expression can also be defined using finite automata, or simply you can call it FA. So what is finite automata? Let's dive into it. So this is a simple finite automata. In finite automata we have different states, and states are represented by circles. So like here we have three states: state X, state Y, and state Z. And one of the state may be the starting state, and starting state is represented by a minus sign, by a dash sign. So this state means you will always start from here, and there may be some accepting state, and accepting state is a plus sign, like this is a plus sign. So whenever you read a string, if the string ends at the accepting state, then you know that string is accepted. You can say that accept string is a word of that particular language. But if you do not end at the accepting state, it means that string is not accepted. So for instance, let's study this automata, this diagram. Here you know we have it says if you read A, this is a starting state, you will always start from here, and if you read A, you will move to the state Y, and if you read B, you will move to the state Z. So keep in mind all the time when you start with a state, you will have to check for all the paths for all the possible letters. Like here we have just two letters, A and B, so we will find the path for A as well as for B at this state. Similarly, at state Y we will find the path for letter A and letter B, and in the same way for this state we will find the path for A and B. So at each state you will find the path for each possible letter in that language. So here this automata says if you read A at state X, that is the starting state, you will go to Y, but if you read B, you will go to the Z, that is the accepting state. And if you read A at the state Y, you will go back to the X, but if you read B, you will end up in the accepting state. So here you can figure it out that whenever you read a letter B, whether you are at the X state or the Y state, you end up at the accepting state, that's the Z. And once you are here, you stay here no matter whatever you read. So I think you can guess that this machine accepts all those words which have the letter B. So if the letter B occurs even one time, the word will be accepted. So like if you have simple B, let's see it, this simple B would be accepted because for single B you will end up here. And let's say if you have A, B, A. So here let's read this string and run this string through this machine. So let's see what happens. Let's start from here step by step. So you read letter A and you start from starting state X, you will go to the state Y, and then you read letter A, you will come back to the state X, and then you read the letter B, and once you find a B, you will ultimately reach the accepting state Z. And once you are here, you are not going anywhere, you will stay here no matter whatever letter you read. So here you read a letter A again, so you stay here. So because this word contains the letter B, it will be accepted. So for this scenario, this is a regular expression, and which says the word must contain a letter B. It can be followed by anything, you can call it anything including null, and it can follow anything, it can be followed by anything, and it can be preceded by anything, so that you can call it anything. So this is a sample finite state automata. And for the FA or finite automata, you can draw a transition table as well. To draw the transition table, in the first column you list down all the states that you have in this automata. Here we have 3 states, X, Y, and Z. And in the first row, you have all the possible letters that you have in that language. Here we are just dealing with 2 letters, A and B, so we list down these 2 letters. And at each state, you will define the next state for the given letter. Like if you are at state X and you read A, you will move to state Y. And if you are state X and you read B, you will end up at state Z, and so on. So this table is very helpful for understanding the automata, and you can also use this table to program the automata, like in switch case programming methodology, if you are going to program the FA for some language processing or text processing purposes. So that's it. So in the next lecture, we see some more examples of finite state automata.